Now, before we look at the more difficult trigonometric functions and graphs question from Leaving Cert 2014, let's just look at this very basic, almost a junior cert style question, okay? Because we just want to get the theory behind it. And we have a green quadratic function and we have a purple linear function. And the first thing to spot is that, like, g of x equals 8 doesn't look like a function. But like usually you'd expect a linear function to be something like 3x plus 2 or 5x minus 1. But when you see g of x equals 8, you should know straight away that that's a horizontal line through 8. Okay, now we're looking for the point of intersection between these two functions, and obviously we can't use the graph to solve it. So anytime you can't use a graph to solve something in functions and graphs, well, you use algebra, right? So in this case, the technique in algebra to solve this is our simultaneous equations. Okay, now there's a couple of different ways you can do simultaneous equations, but in this scenario, probably the best way is, well, we want to know where this function is equal to this function. That's what we're looking for here. So we just put the two functions equal to each other. And now we just use simple algebra to solve. So take 8 from both sides, factorize your quadratic whatever way you see fit, solve your quadratic to get the roots of that quadratic. And then we know that the y coordinate is going to be 8 in this case, so our two coordinates are -1, 8 and 5, 8. Okay, and it should be immediately obvious that that a in this case is 5, 8. All right, we don't need to worry about -1, 8. We were only looking for 8. Now let's see how this is relevant to the one we're doing in the trigonometric functions question next. Now the first thing to note here, right, okay, so is we've two functions, right? The dark one is f of x, which is sine of 2x, and we have a line 2y equals 1. Again, the first thing to spot here is that, right, what does that mean here? 2y equals 1. They're obviously on about this dotted line here, but if you rearrange this equation to get y on its own, we get y equals a half. So, and that makes sense there. Look, that's the function y equals a half. So that's just to kind of throw you off there a small bit, that you should spot that the equation of this line is y equals a half. Okay, so the equation of the trigonometric function is y equals sine of 2x. The equation of this line is y equals a half. Okay, now on the same diagram, sketch the graphs of sine x and 3 sine 2x. Okay, now we'll just zoom in on this there a small bit. So that's our original function, just that's the f of x, sine 2x, and now we want to put in there sine of x. Now anytime you're trying to draw a function, we need two things. You need to know its range and you need to know the period. Okay, and sine of x, straight away when you see that, the range of that is going to be 1 to 1, right, because it's just a regular function, and there's no number in front of the x, so the period is going to be 360 degrees. Okay, or in this case it's 2 pi because it's in radians. So that means that it's going to be the exact same height as the original function that we have here, the sine 2x, and it's going to repeat itself at 2 pi. So it's going to go through the x-axis at pi and repeat itself at 2 pi. Right, so that's what it's going to look like. So that's g of x in this case, and it says h of x then is 3 sine 2x. Now 3 means that the range of this function is going to be 3 to 3. There's no midline, or the midline is 0, so there's nothing complicated there. So the range is going to be from 3 to 3, and the period this time is going to be half the original period. So half the period of this, right? That's what that 2 is. So the period is going to be pi, or 180 degrees, right? So now whatever way you want to draw that now is kind of up to you. What I would be doing is I'd be marking in the period, right? So the period is here, which means that half the period is going to be here, so it's going to go down through the x-axis at here, and its turning point is going to be directly above this red line here, but it's going to be at 3. Okay, so it's going to go up to 3, down through the x-axis, down through -3, and it's going to go back up through pi, right? And then it's going to repeat the same process down the other side. Okay, so that's 3 sine 2x there. Right, so hopefully that's clear. So the red one is the original line that was already on the paper. The purple line is this, 2y equals 1. The blue line is sine of x, and the green line is 3 sine 2x. Now, then we want to find the coordinates of p. Now, that's kind of, so these two functions are irrelevant in this question. Okay, p isn't on the green function, it's not in the blue function, so we can kind of ignore the green and the blue function now. And we're focusing on the purple line and the red line, and clearly we want to find a coordinate where those two meet. First thing you should know is that you can't use the graph to figure this out. Right? It's very difficult to figure out exactly what values between pi and 2 pi here. So when that happens, it must be algebra that we need to use. Now all of this can be translated into the following. All right, we just want to find the values for x where the function f of x, which is the red function, is equal to y, which is the purple function. And that helps us form the following equations. We know f of x is sine of 2x. We know y is equal to a half. So if we just put them equal to each other, like in the previous example, the simpler example, we now just need to solve this equation. And that's just a simple trigonometric function. that we need to solve. So the steps for this you should know off by heart. So first off, we're looking for a reference angle. Now I know it's a small bit blurry there, but look, sine of A is equal to a half when A is equal to pi over 6. So pi over 6 is our reference angle. We then need to plot that on the unit circle. So pi over 6 is here on the unit circle, and we know that each of these three angles as well have, our second angle is going to be one of these three angles. Okay, and to figure out which one, we know that sine is positive in the first and the second quadrants, so it's going to be this angle here. So how do we find that angle? Well, we know that this angle in here is pi over 6, so to find this angle from this direction, we just say pi minus pi over 6, which is 5 pi over 6. Right, so these are our two angles. Now we want the general solution, and you'll see why now in a second that we need the general solution. So when we put this into the general solution, now we get rid of this 2 by dividing everything across by 2. So our two general solutions for the angle that we're looking for is pi over 12 plus pi n, or 5 pi over 12 plus 5 pi n. Now next up into our general solution, we're going to sub 0 and 1 as we usually do. And just look, I didn't do the actual substitution here, I just gave you the solutions. But look, when you sub 0 into this, we get pi over 12. When you sub 1 into this, you get 13 pi over 12. And similarly, when you sub 0 in here, you get 5 pi over 12. And when you sub 1 in here, you get 17 pi over 12. So look, I didn't do the actual calculations here, but hopefully you follow where I got those four solutions. Now the question is then, which one of those is P? Okay, and this is kind of hard to spot, but look, what are we actually after finding there now? We're after finding where sine of 2x is equal to a half, where the red function is equal to the purple function. So look, we're after finding this point, this point, this point, and this point. Right, the first four values were it. So that's one way that we could figure out that P is actually the last one, 17 pi over 12. Right, so if you can spot that, that's fine. That is the fourth point of intersection between the purple and the red. But another way of looking at it is, well, pi, in this case, if we give them all the same common denominator, so if we gave pi a common denominator of 12, it would be 12 pi over pi, or 12 pi over 12. So obviously 13 pi over 12 is that coordinate there. Pi over 12 is the first one there. 5 pi over 12 is that one there. And lo and behold, 17 pi over 12 is that one there. Okay, so that's our coordinate. The coordinate is 17 pi over 12 comma a half, right? Because we know the y coordinate has to be a half.